Okay, we're going to look through these practice problems real quick. We're told we got a continuous function here. So that tells me two things. That tells me my function value at any number in the domain of this is equal to the limit as x approaches that number. So I'm going to be kind of focusing on the number x equals 5 because that's where the jump in the graph happens. And that's going to allow us to relate this equation with b to this other equation. So what this tells me, the fact that the function is continuous, tells me f of 5 will equal the limit as x approaches 5 of my function f of x. So f of 5 equals the two-sided limit. Well, for a two-sided limit to exist, the left limit and the right limit have to exist and have to equal each other. So I know the limit as x approaches 5 from the left of my function equals the limit as x approaches 5 to the right of my function. And that'll get me an equation. And then furthermore, I know that both of those happen to equal f of 5. So let's figure out what f of 5 is here. So f of 5 equals, if I look at the one that has the word equal, that's the top one. I plug 5 into that form. So this is going to be 25 plus 5b. So 25 plus 5b, that is f of 5. That equals my two-sided limit. Well, my left-hand limit equals my right-hand limit, and both the left and right-hand limit equal the two-sided limit. Since the two-sided limit equals f of 5, and f of 5 is really 25 plus 5b, I can say that both of these equal 25 plus 5b. So I'm going to look at mainly the right-hand limit equals 25 plus 5b. So the limit as x approaches 5 from the right of f of x equals 25 plus 5b. So this says limit as x approaches 5 from the right of 5 times sine of pi times x over 2 is equal to 25 plus 5b. So this limit, if I think letting x get closer and closer to 5, as x approaches 5, this is going to approach 5 pi over 2. And sine of 5 pi over 2, if you think about the unit circle, sine of 5 pi over 2 is coterminal to pi over 2. Sine of pi over 2 is 1. So this will be the same thing as 5 times 1 equals 25 plus 5b. We can subtract 25 across. 5 minus 25 is negative 20 equals 5b. Divide by 5, negative 20 divided by 5 will be our b value, and that will be negative 4. So negative 4 should work in this case. That is my b value to make both of these match up at 5. Okay, let's see here. Then we look at the next one. Is this function continuous at x equals 3? Why or why not? So 3 things to check. First of all, what's my function value at 3? My function value at 3 says use the top form because that's who's equal to 3. This will be square root of 3 plus 1 equals square root of 4 equals square root of 4 is 2. Okay, then I need to check, is my two-sided limit at 3, what is that? So here we have 2 different forms, so I need to check my left-hand side, my right-hand side, and verify that they are the same thing. That'll get my two-sided limit. Then I can check my two-sided limit against my function value. So I need limit as x approaches 3 from the left of f of x, and I need limit as x approaches 3 from the right of f of x. So limit as x approaches 3 from the left of f of x is limit as x approaches 3 from the left of square root of x plus 1, which we can use our basic limit stuff and say that this will be square root of limit as x approaches 3 from the left of x plus limit as x approaches 3 from the left of 1, which is square root of limit as x approaches 3 of x is just 3. Limit as x approaches 3 of 1 is 1. This is square root of 4, which is 2. So my left-hand limit equals 2. My right-hand limit as I approach 3 is limit as x approaches 3 from the right of 5 minus x, which is the limit as x approaches 3 from the right of 5 minus the limit as x approaches 3 from the right of x. So that is going to be limit as x approaches 3 of 5, 3 from the right of 5 is just 5, minus limit as x approaches 3 from the right of x is 3. 5 minus 3 is 2, so okay. 5 minus 3 is 2, I wrote a 3. So this is good. These two are the same. Since those two are the same, oh my gosh. Since those two are the same, that tells me that the limit as x approaches 3 of f of x is 2. So then I compare and say, okay, my two-sided limit, they were the same. So my two-sided limit is 2. My function value here is 2. These two are the same. And these two being the same tells me I'm continuous. So we can say f of x is continuous at x equals 3 as limit as x approaches 3 of f of x is the same as the function value at 3, and they both equal 2. And that will wrap up that problem. So we had to show that the left and right hand limit were the same. Once they were the same, that got me my two-sided limit existed. Then I needed to check my two-sided limit against my function value. All right, final one. Which of the following is continuous at 0? 1 and 2 I can graph and kind of think about. So 1 is absolute value. So we graph it, and we can see the left-hand limit approaches 0, the right-hand limit approaches 0, and the function value is at 0. So all three of those are 0. So 1 should be fine. It's continuous. E to the x's graph looks like this. So the left-hand limit approaches 1, the right-hand limit approaches 1, and the function value is at 1. So e to the x is fine. Let's see this one here. I'm not sure what that graph looks like. So let's see what the function value is. Let's see what the two-sided limit is at 0, and then compare them. So let's say for part 3, what is f of 0? Let's get the function value. That's natural log of e to the 0 minus 1 is natural log of 1 minus 1 is natural log of 0, which is not defined. So 3 is out. We don't have a function value there to be continuous at. So it doesn't matter if the two-sided limit exists or not. If the two-sided limit doesn't exist, or if the two-sided limit exists, it can't equal something that's not defined. So our answer for this one here is just going to be 1 and 2. So we will stop there.